So 2022 paper 2, and this is from the deferred paper. So the number of matches in each of 53 boxes of matches was counted. The results are as follows. So along the top we have number of matches, and underneath we have number of boxes. So just, I suppose, to give a quick explanation here. This first one, for example, it simply means that in 3 of those 53 boxes, when opened, there were 41 matches inside. Whereas here, for example, somebody discovered that in 8 of the 53 boxes, when opened, there was 42 matches inside, etc. So what we're asked to do is draw a suitable chart to show this data. Now, a suitable chart, so when you think about a chart, I mean, we've had things like pie charts, bar chart, histogram, our stem and leaf, scatter plot, okay? But here we have number of boxes, which is numerical discrete, number of matches, which is also numerical discrete. So for that reason, whole number answers, something we can count. So for that reason, I'm being pointed towards bar chart. So in other words, we're doing a chart where there is gaps, whereas with the histogram, there's no gaps. And the reason there's no gaps is because it's continuous data, which essentially means it's something you measure rather than something that you count. So we don't expect whole number answers. So a bar chart is what's suitable here. I just snipped it out actually so that I don't have to draw it now. Usually whatever's on top of your table is bottom of your graph. So there we go. With this, I would have actually put in the break in the graph just to show that I'm not starting at 0 along the bottom. I'm starting at 41, 42, 43, 44. Just when you're dealing with numbers, you have to be a bit careful that there's not a misconception. Up the side, so the lowest number of boxes we have is nothing, and the highest number is, I think, 17. So that's why it's a good idea. I mean, going up in 1s would take too long, and you don't want to go up, you know, in 5s or something like that when the highest number is 17. So going up in 2s absolutely makes sense. Notice there is even gaps between the bars. So whatever the gap is there, the gap should be the same. Okay, that's really important the whole way along. If, for example, there was no boxes where there was, you know, let's say there was no boxes that had 45 matches, would you still include the 45? Yes, you would, but there just wouldn't be a bar there. You know what I mean? You'd still include the 45 and then you leave a gap. The reason I'm saying that is because sometimes students feel if there is no boxes with 45 matches, then we don't need to worry about it or think about it or include it. But actually you do. The gap is often more significant or the most significant feature in a chart. So we always include a gap if that gap exists. It doesn't in this case. So there's your pie chart. Notice I have labels. Again, notice these are all evenly spaced. Okay, and we're obviously going up in 2s, so we're keeping that pattern the whole way. Right, so then we are asked to find the mean, mode, and median number of matches per box. Give the mean correct to 1 decimal place. Okay, now we have a calculator, of course, but I think given the fact this is quite a simple example, I'm going to go back up here. So how do we do the mean? So the mean, I'm just going to get rid of this for a sec. So when we have, this is called a frequency table. So when we have a frequency table and we want to do a mean, what we are doing is we are multiplying top and bottom the whole way along. So 41 by 3 plus 42 times 8 plus 43 times 16 plus, and we keep going. Now, why is it that we're doing that? So, you know, is it just like, oh, we just need to learn off this method, or is there a reason? So yes, of course, there is a maths reason. I'll just fill in the bottom line and then I'll explain. So all I'm doing here is filling in the bottom numbers. Okay, so just to explain, I would have explained this in class, but just to reiterate, when you have a frequency table, we're saying that there are, as I said, 3 boxes with 41 matches in it. So really it's like saying you have 41 matches plus 41 matches plus 41 matches. Then we're saying that there are 8 boxes with 42. So it's like saying plus 42, plus 42, plus 42, plus 42. And doing that 8 times. Now, as you can see, I hope I've made my point, this isn't really something we want to be doing, having all these numbers, massive long lines. So that's why it's 41 times 3, because you're saying 41 is there 3 times. 42 is there 8 times. So instead of writing 42, 42, 42, 42, 42, 42, 42, 42, we're doing 42 times 8, and we continue and so on. So that is why it is what it is. Now, of course, given the technology we have these days, we can also use the stats function and input the data in a table, and we can just read the mean directly off. So you can do that as well, but I suppose I just wanted to show you that given the fact that it was a straightforward one. So I'm just going to do it as I have it written on the page. So I'm doing my 41 times 3 plus 42 times 8 plus 43 times 16 plus 44 times 17 plus 45 times 8 plus 46 times 1, and then underneath the line 3 and 8 and 16 and 17 and 8 and 1. Okay, so now we're asked to correct, what are we asked to do? So we're asked to correct the mean to 1 decimal place. So the mean turns out to be 43.4. Now, we're asked for the mode. Well, the mode is always the easy one, isn't it? It's the one that occurs most often. So having 44 matches in the box occurs more often. It occurs 17 times. So it occurs more often than any other number in the box. So that's why we're giving the answer of 44. So our mode is 44. And then we're asked for the median. Now, remember the median, anything to do with median means it has to be in order. So we're checked first, is it in order? Well, 41, 42, 43, 44, it is absolutely in order already, in ascending order. So that makes it a bit easier for us, because if I want to get the median, remember, I need to go halfway. Now, if you can imagine, if I lined up the match boxes according to how many matches were in the actual box, I'd have 53 boxes all lined up, one after another, something like that. A big row of them. Now, what's important here is, if I'm looking for the median, I'm looking for the middle value. So would it make sense that I would say if it's 43, I'd have, let me think, 26, isn't it? 26 on the left, 26 on the right, and I'd have 1 box in the middle. So just take that, 6 and 6 is 12, and 1 is 13, 2, 4, 53, yeah. So would we agree that the 27th box is the median box? Now, when I'm trying to find the 27th box, I start off here and I say, okay, well, at this stage, have I met the 27th box? Well, I haven't, because I've only met 3 of them. If I keep going, I have now looked into or come across 11 of the boxes. So have I met the 27th box? Have I come across the 27th box? Well, I haven't, because I've only come across 11. So I have to keep going. Now at this stage, I've come across 20, so that's 16 and 8, 24, 25, 6, 27. So actually, at this stage, the 27th box is actually present here. So for that reason, the median is 43. I don't need to go any further because I have found the 27th box, or I at least have found the group that the 27th box is in. So the answer for the median is 43. So the answer for the median is 43. And just also, I mean, a lot of data is symmetrical. Doesn't have to be, but if it's more or less symmetrical, then you expect the mean, mode, and median to be very similar. So if you've got a figure that's way out, check your working, because there's a chance perhaps you've done something with the calculation.